Good day, everyone. I'm Christian Dominic Samson, BS AMT. Subject is Aircraft Materials Construction and Repair Lecture, and I am under Sir Mr. Vincent Michael Pabustan. So, subject code is AMT 15144. So, I'm about to explain the major structural stresses that affects the aircraft structure and various aluminum alloy used in our aircraft. So we have to divide it into two parts. So first part is the major structural stresses of the aircraft. So we have to focus on that one. Aircraft structural members are designed to carry a load or to resist stress. In designing an aircraft, every square inch of wing and fuselage, every rib, spar, and even each metal fitting must be considered in relation to the physical characteristics of the material of which is made. Every part of the aircraft must be planned to carry the load to be imposed upon it. The determination of such loads is called stress analysis. Although planning the design is not the function of the aircraft technician, it is nevertheless important that the technician understand and appreciate the stresses involved in order to avoid changes in an original design through improper repairs. The term stress is often used interchangeably with the word strain. While related, they are not the same thing. External loads or forces cause stress. Stress is a material's internal resistance or counterforce that opposes deformation. The degree of deformation of the material is strain. When a material is subjected to a load or force, that material is deformed, regardless of how strong the material is or how light the load is. So, we have five major stresses on acting on our aircraft. So, first one is the tension, compression, torsion, shear, and bending. So, first is the tension. Tension is the stress that resists a force that tends to pull something apart. The engine pulls the aircraft forward, but air resistance tried to hold it back. The result is tension, which stretches the aircraft. The tensile strength of the material is measured in pounds per square inch or PSI and is calculated by dividing the load required to pull the material apart by its cross-sectional area. So, example, this pen. So, both ends, you are both trying to pull. That is where our tension stress occur. When both ends you are trying to pull, or trying to pull something apart, that is what you call tension stress. Example, this is your aircraft. So this is where your engine. So your engine is trying to move forward, but the air resistance is trying to hold it back. So where tends to both ends pulling. So that is where your tension stress occur. So second one is the compression. Compression is the stress that resists a crushing force. The compressive strength of a material is also measured in PSI. So, compression is the stress that tends to shorten or squeeze aircraft parts. So, example, again, compression from the word itself, compress. So, it compresses. You are trying to crush or you're trying to squeeze the aircraft. That is what you call a compression stress. That is where compression stress occur when you are trying to crush or you're trying to shorten. So third one is the torsion. Torsion is the stress that produces twisting. While moving the aircraft forward, the engine also tends to twist it to one side, but other aircraft components hold it on course. Thus, torsion is created. The torsion strength of a materials, it is resistance to twisting or torque. So, example again, torsion. You are trying to twisting. So that is where torsion, this is torsion looks like, trying to twist both from this forward and this backward. So you are twisting the aircraft. So that is what you call torsion stress. Next is shear. Shear is the stress that resists the force tending to cause one layer of a material to slide over an adjacent layer. So example, riveted plates. So two riveted plates in tension subjected the rivets to a shearing force. So this is your riveted plates. So in the middle is your rivets. So you usually the shearing strength of a material is either equal to or less than its tensile or compressive strength. Aircraft parts, especially screws, bolts, and